Opening approach. Start from a broken comparison that appears in dashboards and explain why the mismatch comes from incompatible energy accounting rather than scale itself. Build tension between headline-level output comparison and ground-level grid physics, moving from capacity illusions into real generation constraints. Unique angle. The claim collapses because it mixes two different electricity realities. China is reporting a highly optimized, transmission-extended system, while India is reporting a more localized, constraint-bound grid. Mood applied. Frustrated and controlled. The numbers are real, but the way they're being compared is sloppy. There's a moment when you look at global electricity dashboards and something immediately feels off. Not wrong in a dramatic way, just misaligned. Like two data sets that were never meant to sit in the same column, but somehow ended up being compared anyway. That's where this claim comes from. Chinese wind farms produce more power than India's entire grid. It circulates because it feels intuitive. Big country, big infrastructure, big numbers. But the problem starts earlier, before any conclusion is even possible. It starts with what people think power actually means. Installed capacity is not electricity generation, and electricity generation is not usable electricity delivered to end demand. Those three sit in completely different layers of the system, and when you collapse them into one comparison, you don't get insight, you get distortion. Let's anchor this in actual scale first. China's wind fleet is now well above 400 gigawatts installed. India's is roughly 1/10 of that. That gap is real and measurable, and it didn't happen gradually. It accelerated through China's coastal offshore expansion and its massive inland wind corridors across Gansu, Xinjiang, and Inner Mongolia. So if you stop there, the story looks obvious. But electricity systems don't stop at installation. They move through a second layer that almost never appears in viral comparisons: utilization. A turbine sitting in a wind-rich region doesn't automatically translate into delivered energy. It depends on how often it spins near rated capacity, how stable the wind resource is, and whether the grid can physically absorb what it produces at that exact moment. This is where capacity factor becomes the quiet divider between perception and reality. China's newer wind infrastructure, especially offshore, operates with capacity factors often in the 35 to 45% range under favorable seasonal wind regimes. That's high by global standards, and it reflects both geography and engineering scale. India's wind fleet, while strong in specific corridors like Tamil Nadu and Gujarat, often operates closer to 20 to 30%, not because the wind resource is fundamentally weak, but because generation is frequently constrained by grid absorption limits and transmission bottlenecks. And this is where the comparison starts to bend. Because now you're no longer looking at how much exists, but how much is allowed to move. China's system was forced over the last decade to solve a problem India is still actively dealing with. What happens when generation is built faster than transmission? In northern China, wind and solar projects expanded faster than local demand could consume them. The result was curtailment. Turbines literally shut off while wind was available. In some provinces, that curtailment exceeded 15% during peak mismatch periods. That number is not a side detail. It's the reason China started building ultra-high voltage transmission lines at scale, pushing electricity thousands of kilometers from interior provinces to coastal industrial hubs. India's grid hasn't had to solve that exact version of oversupply yet. Its constraint is different. It's not about moving excess power across vast distances, but about stabilizing regional supply without overloading transmission corridors that are still evolving. So when someone compares Chinese wind output to India's entire electricity system, they are implicitly assuming both systems treat geography, transmission, and demand in the same way. They don't. China's grid is increasingly a long-distance redistribution machine. India's grid is still largely a regional balancing system stitched together at the national level. That difference alone reshapes what output even means. And this is where I start questioning the framing itself, not just the conclusion. Because if you're comparing systems that don't share the same architecture of movement, then the comparison isn't measuring scale. It's measuring structure under different rules. The uncomfortable part is that both numbers are real. China's wind generation is enormous. India's total grid demand is enormous. But placing them side by side without context turns engineering differences into a misleading hierarchy. And I'm not convinced most of the internet is actually looking at the same definition of power when they repeat that claim. Start by breaking the illusion that more turbines equals more usable electricity, and shift into how geography and demand placement decide real output. Move from generation physics into geographic demand mismatch and how each country solves or struggles with spatial energy distribution. The real gap isn't wind potential. It's that China aligned its wind farms with a continent-scale redistribution network, while India is still negotiating energy geography at a smaller but more fragmented scale. Frustrated and controlled, the system design choices matter more than the headline suggests. There's a mistake people make when they look at energy systems like they're looking at factory output. As if you build more machines, you automatically get more usable product. Electricity doesn't work that way, not even close. Because the moment you generate power, you immediately run into the real constraint, where it is and where it needs to be. China's wind expansion didn't just happen in windy places. It happened in places that were structurally inconvenient for demand. Inner Mongolia, Gansu, Xinjiang, regions with enormous wind potential, but nowhere near the coastal industrial clusters that actually consume most of the electricity. So what you get is a spatial imbalance baked into the system from day one. And China didn't try to avoid that imbalance. It scaled into it. That decision matters more than it sounds. Because once you commit to generating power far from demand centers, you are forced into building something that looks less like a national grid and more like a continent-wide energy transport network. That's where ultra-high voltage transmission comes in. Long-distance, high-efficiency corridors designed to move electricity across thousands of kilometers with reduced loss. Lines stretching from the interior to Shanghai, Zhejiang, Guangdong. Not incremental upgrades, structural rewiring of the map. India is not operating at that same spatial scale of mismatch. Its wind generation is heavily concentrated in Tamil Nadu, Gujarat, and Karnataka, regions that are already closer to major consumption clusters compared to China's western interior. That reduces the extreme long-distance transmission burden, but it introduces a different constraint, regional congestion. Instead of how do we move electricity across a continent, the problem becomes how do we stabilize flow within a more tightly packed but still uneven grid. So when people compare total output, they ignore that China is constantly paying a hidden infrastructure cost just to make its wind generation fully usable. Without those transmission lines, a significant portion of that output would remain stranded or curtailed. And curtailment isn't theoretical. It shows up in real dispatch decisions. Turbines turned off not because wind is absent, but because the grid cannot absorb it at that moment without destabilizing frequency or overloading lines. That's the part that rarely enters viral comparisons. Now, zoom out slightly. China's energy system is designed around absorbing inefficiency at one stage in order to eliminate it at another. Build first, stabilize later. Overcapacity is not treated as waste. It's treated as a buffer against future demand uncertainty. India has historically leaned toward the opposite instinct, more incremental build-out, tighter alignment between projected demand and generation expansion, less stranded infrastructure, but also slower emergence of surplus capacity. Neither model is inherently superior, but they produce completely different shapes of energy reality at any given moment in time. This is why the headline feels misleading even when the raw numbers are technically correct in isolation. Because more wind power in China does not mean simpler or cleaner dominance over another grid. It means a system that has accepted massive geographic dispersion and is actively engineering its way out of the friction that creates. India's grid, meanwhile, is still dealing with a more immediate set of constraints. balancing reliability, managing peak demand volatility, and expanding transmission without creating large pockets of instability. And here's where I pause and question the comparison itself. What does entire grid even mean in this framing? Is it annual generation, peak load, installed capacity, dispatchable output during peak hours? Because each of those tells a different story, and none of them align neatly across two countries with different industrial structures and different grid maturity stages. The truth is, this isn't really a comparison of wind farms versus a national grid. It's a comparison of two different answers to the same problem. How do you move electricity from where it is cheapest to generate to where it is most valuable to use? China answered it with distance and infrastructure scale. India is still answering it with regional balancing and gradual integration. And until you align those definitions properly, the numbers will keep producing conclusions that sound decisive, but don't actually survive contact with how electricity flows in the real world. Start by introducing the hidden efficiency illusion in China's wind expansion, why high output can coexist with serious system friction. Push into system contradictions, China's overbuilt generation versus grid absorption limits, then contrast with India's underbuilt but more constrained expansion logic. Unique angle. China's wind dominance is not a smooth success story. It's a system constantly correcting for its own overbuild, while India is still in the stage of preventing those imbalances from emerging at scale. Mood applied. Frustrated and controlled, the story gets more complicated the deeper you go, not simpler. There's a point in almost every large energy system where scale stops feeling like strength and starts feeling like friction. China is not past that point. It's sitting right inside it. And this is where the comparison with India starts to distort in a different way. Not because the numbers are wrong, but because they hide the cost of getting there. China's wind output looks dominant on paper. Annual generation is massive, growing every year, and increasingly supported by offshore installations that perform far better than early inland farms. But behind that growth sits a system that is still actively dealing with mismatches between generation and consumption. Curtailment is the clearest signal of that mismatch. Even after massive transmission buildouts, certain provinces still experience periods where wind output exceeds what the grid can safely carry or what demand can absorb at that moment. That excess doesn't become electricity. It becomes potential that never leaves the turbine. So when someone says China produces more wind power than India's entire grid, they are accidentally mixing two states of the system. One where generation is allowed to exceed immediate demand, and one where generation is still being carefully matched to avoid instability. India hasn't scaled into that overcapacity zone yet. Its constraint is earlier in the pipeline, and that changes how inefficiency looks. In China, inefficiency shows up as curtailment, redundant capacity, and massive infrastructure spending to move energy across regions that were never naturally connected at that scale. In India, inefficiency shows up differently, as delayed expansion, transmission bottlenecks that limit renewable absorption, and slower integration of high variability sources into a grid still anchored by coal and hydro balancing. One is a system dealing with excess, the other is a system dealing with constraint, and both are real bottlenecks, just at different stages of maturity. Here's where it gets more interesting. China's policy approach has often tolerated what engineers would call systemic overbuild. It's not accidental, it's strategic. Build generation ahead of demand curves, then expand transmission and storage aggressively to catch up. The assumption is that coordination can be retrofitted after scale is achieved. India has historically leaned toward the opposite constraint logic. Try to expand generation in step with demand growth and avoid large mismatches that could destabilize regional grids or create stranded infrastructure. That difference sounds technical, but it produces completely different energy landscapes. China's landscape is one where you often have too much electricity in the wrong place at the wrong time, and then a parallel infrastructure race to correct that imbalance. India's landscape is one where electricity scarcity is less about generation potential and more about delivery reliability and grid flexibility. So when you compare wind output directly, you're not comparing two equivalent endpoints. You're comparing two systems sitting at different points along a tension curve between generation and integration. And I keep coming back to this question because it matters more than the headline itself. Is higher wind output always evidence of a stronger energy system? Because if that were true in a simple sense, then curtailment wouldn't exist. Transmission constraints wouldn't matter. Storage would be irrelevant. But every large grid in the world eventually runs into the same problem. Generation is easy to scale. Integration is not. China is currently living in that second half of the problem at scale. India is still expanding the first half while carefully avoiding the worst of the second. That's why the comparison feels unstable when you look at it closely. It assumes both countries are solving the same equation in the same order. They're not. And I'm not entirely convinced the popular narrative even acknowledges that distinction. It tends to treat output as proof of completion rather than proof of transition. But neither system is finished. China is still smoothing out structural imbalances created by its own speed. India is still building the depth required to avoid those imbalances in the first place. And the further you go into the data, the clearer it becomes that scale alone doesn't tell you which system is ahead. It only tells you where the pressure has already started to accumulate. It only tells you where the same version's energy transition bill. The most far as those dominants in the real comparison isn't China versus India output. It's which country is better at absorbing the instability that renewables inevitably create at scale. Frustrated and controlled, ending with clarity but not comfort. At some point, the comparison itself stops being useful, not because the data is wrong, but because it's answering a question that electricity systems don't actually care about. Who produces more sounds like a final metric. In reality, grids don't end at production. They end at stability. And stability is where China and India are dealing with two different phases of the same problem. China's wind system is already so large that the main constraint is no longer building generation. It's absorbing it without breaking balance. That means curtailment in certain regions, constant reinforcement of transmission corridors, and an ongoing push towards storage and grid flexibility just to keep utilization high. India is not there yet. Its constraint is earlier in the chain, expanding generation fast enough while simultaneously strengthening transmission so that new renewable capacity doesn't immediately hit bottlenecks the moment it comes online. So when the headline says Chinese wind farms produce more power than India's entire grid, it's mixing a system that is already struggling with post-saturation dynamics with a system still scaling its foundational layers. That's not a clean comparison. It's two different chapters, and the uncomfortable truth is that both chapters come with their own hidden costs. China's cost is overbuild friction, generating more than can be smoothly absorbed in real time, then spending enormous capital to reduce that mismatch through ultra-high voltage lines and regional balancing mechanisms. It's an efficiency problem at scale. India's cost is underbuild pressure, slower accumulation of surplus capacity, tighter margins during peak demand periods, and a grid that still has less room for experimentation with high variability sources at extreme scale. It's a resilience problem under growth. Neither is a stable endpoint. And this is where I start to step back from the headline entirely. Because if you strip away the comparison framing, what you're actually looking at is something simpler and more important. How two of the largest energy systems on Earth are handling the same physical constraint in different sequences. Electricity has to be generated, transmitted, and consumed in near real time. That constraint doesn't care about policy narratives or national ambition. It only responds to infrastructure alignment. China chose to front-load generation and force transmission to catch up. India is trying to co-evolve both more carefully, but at a slower aggregate pace. So who produces more wind power becomes less meaningful than who is building a system that can keep that power usable under stress. And if I'm being honest, that second question is still unresolved in both cases. China is still proving it can fully integrate the scale it already built. India is still proving it can scale integration fast enough to match its next wave of generation expansion. I'm not fully convinced either system has reached a steady state yet. The data still looks transitional, not settled. But I am convinced of one thing. The moment you see a headline comparing total wind output to an entire national grid, you're not looking at a conclusion. You're looking at two infrastructures mid-construction being mistaken for finished products. And that mistake tends to age badly. If there's one thing worth watching over the next decade, it's not just how much wind capacity each country adds, it's how much of it actually survives the journey from generation to consumption without being clipped, delayed, or stranded along the way. Because that's where the real competition lives, not in the turbines, in the space between them and the people using the electricity. If you found this useful, stick around. Next time I want to look at something even more uncomfortable. What happens when renewable overcapacity stops being a strength and starts becoming a grid liability in disguise?